the class we're taking?
My ride's actually paid for me in the parking lot.
Oh, really?
Yeah.
Yeah, we'll fly through the slides. We're gonna go through them. We got a few, but not many.
You do it, we're driving all the way back and then back again.
Well, I've noticed since I've gotten a room about 20 minutes ago, the wind's really picked up.
It's still snowing though.
Yeah, wind's really picked up outside. And the snow, it looks like we're getting a lot, but I think we're only supposed to get another 1.5 to 2 inches between now and 3 a.m.
Yeah, but that wind blows that snow. It's already
There'll be a lot. There'll be a lot of drifting. You're right. There will be a lot of drifting.
especially like an open field. That's where you can tell.
Yeah, right. Going right across the like you do 173 home.
Yeah.
Yeah, it'll go right across the road. Yep.
Wind was mostly blowing from west to east, so that's actually a better idea, I guess, if you're 173.
Okay.
Instead of having to go north and south.
Right. Well, at least that's good.
Yeah, some areas are better than others. It depends where you're at, where the weather is. They plowed it.
Well, the colder it gets and the more wind it blows, it'll definitely get worse. Especially on the roads that have been plowed or plowed very little and have had no salt or anything.
Right.
Because it's pretty wet and slushy. Because if it drops, it's going to be. Whew,
Yeah, it's just good for
it's real slushy out there.
Goes straight up black ice.
Yeah.
That's the most.
I was surprised how deep the slush was in some of those plots in the parking lot. It's like about that deep of slush. I'm like, wow.
And they're working on it too. They're not,
Yeah, they keep moving it. It just keeps coming down.
Yeah.
Oh well, it's winter. Spring will be here before we know it. Yeah, everybody's ready for that, right? How's it going?
That worked great.
Oh, that's so good. Are you?
Yep.
Hello. Hello.
So,
Maybe you check in online as well in week 5, that check-in module. Put your name in there as well.
okay.
Same as you. Put your name on the check-in module as well.
Yeah.
You can check in with this too.
Yeah.
Yep. Thank you. Hello.
Hello.
There you go. I'm gonna have you check in on the check-in module in week 5 as well as checking in here. Cool. Hello. I'm gonna have you check in on the online module as well in week 5. You get back to your desk. This and there's an online module.
Oh,
Check
so
out check
should I
it.
do it just like-
Yeah, do both.
Oh.
You can do this too. You can do this too.
I forgot my camera.
Okay.
Do we need it in?
No. Not tonight.
It's just the day that
Hmm.
the day that I come to camp.
Yeah. Yeah, you're fine. There you go. Yep. All right, those online, make sure and submit your name in the week 5 module for check-in. We'll get started here in about a minute. All right, we are in week 5. Thanks for coming tonight. Appreciate it. All myself. Yay. All right, well, tonight we're going to be going over hardening your network as far as building infrastructure. And then Thursday, we're going to go over the man-in-the-middle attack when you come in. We'll be doing that as soon as you come in. And that's the one where you'll walk in and there'll be a Facebook page in front of you. I'll have you log in with a bogus username and password. And then I'll stop the man-in-the-middle attack and then have you view it from the man-in-the-middle machine, how it's set up, and then we'll discuss it. And you'll also be able to take that lab home with you and replicate it as well. Make sure you've signed into week 5 check-in module if you've not done that, even if you're here in class. So you get, I did add 10 points to that. So, all right. Assignments this week, chapter 5, review questions and quiz. And after the discussion, we will do a really quick Kahoot over chapter 5. All right, so we're looking at ways to secure a host or a server room, define application security, look at how we deal with loss prevention, how to secure it. So 3 elements when it comes to securing a host. One is the host itself, applications on the host, and data. And when I say the word host, that would be your network server or even the clients in the business that people work on. The host involves on security, the physical device itself, whether it be steel cables like we have here on campus, outside of IT, to the operating system being secure with passwords and such on the operating system. Security-based software applications being used to keep the software up to date and unhackable or unhackable as possible. And then monitoring logs like failed login attempts on a computer, failed login attempts on a server. And those can be red flags that can, mean something's going on that computer or that server. Also preventing unauthorized users from gaining access, like through proximity doors, proximity sensors like we have in this room, or in the server room we have locked doors in the building here, and most businesses will have as well. For sure a lock, if not a proximity lock, some type of lock to lock the door, even if it's a closet, so people can't get into the device easily. And then host hardware security and some type of mobile device security. Mobile device security, mobile device management called MDM is real popular today. That Cisco has a popular one, Meraki that's pretty popular. And then, but there's all your phone companies have them. Verizon, AT&T. You can pay so much per phone and control the phone location, what apps are installed, what apps they can install, stuff like that. I think Verizon's something like $5 or $10 a month or something like that. It's pretty reasonable. And I think AT&T is about the same. So when it comes to physical security, you're restricting access to the room or the closet or the server room by such things as hardware locks. Here on these doors here, we have both proximity and then PIN card as well, or PIN number as well. You can use a fob as well. These little, they look like about the size of your pinky, and they're just gray, and they fit on your keychain, and they can unlock the doors as well. Then deadbolts, you're familiar with those. And not just one deadbolt, might have multiple deadbolts possibly. And then key locks can be compromised if keys are lost, stolen, or duplicated. So if you do have keys, make sure you have key management somebody leaves, or you even if somebody leaves and does return the keys, usually it's pretty good key management to update the masters in the environment. Because even though the master key might say do not duplicate, there are places that people can get them duplicated at. Or you can send them online somewhere and do duplicate, they don't mess with it, or do it themselves. Whole bunch of different ways to compromise key security. So here's a residential door on the left that you're familiar with. On the right is a deadbolt lock. And you'll notice it's got the deadbolt coming through at the top and at the bottom both. The bottom really is just a door entry, not really a deadbolt. The top one's actually the deadbolt portion of it. But it is key. Both of them are key. So on key management, changing locks after key loss or theft, inspect locks regularly, issue keys only to authorized users, keep records of who uses and turns in keys, keep track of issued keys. And master keys should have the identifying marks, do not duplicate, on them. Recommended management procedures, secure in a safe, unused keys. Have some type of monitoring procedure. Mark duplicate master, do not duplicate. Wipe out manufacturer's serial number, prevent duplicates from being ordered. And then cipher lock is more sophisticated to key lock. It's a combination sequence to open the door. Like we have here, we have a cipher lock and a proximity door lock both on these doors here and the Cisco lab and all the office doors. Can be programmed to allow individual codes to be entered in. Records when the doors open by which code. Can also be vulnerable to shoulder surfing. We never use on campus, except for security, the keypad, but they are on the door. They can be used. We do all authentication through proximity card. And then often used in conjunction with tailgate sensor. Again, we don't have to worry about that on campus, except for security that uses it maybe. But I think they still use your badge as well, most of them. That's what it looks like. I think ours is a 9-pin. Then you got 3-pin, you got 6-pin, 10-pin, 11-pin, 12-pin, a whole bunch of different ones. And also, too, by the way, on this lock here, this is a cipher lock only, meaning it's some of them have built into it since it can keep data, a chip or somewhat Wi-Fi device for determining who's accessed the door. And so there might be a battery in them that can need to be changed periodically. And then other methods of authenticating a door be physical token, an ID badge, emits a signal identifying the owner, proximity reader like we have on campus. RFID tags can be affixed inside an ID badge, be read by an RFID proximity reader. Badge can remain in bearer's pocket. And we do it on the doors here. We do it on the copiers now. We go to make a copy, we use up our badges as well. Or on the weekends or whatever, if I need to get in the building, I can use my card to get into the doors here. And then some rooms have, and then we'll talk about in a second, alarms as well, like this room. So that's an RFID is pretty cheap technology, pretty cheap way to secure anything really, device-wise, or even going on the back of a badge. On the right, it's called a man trap. Basically, what this is designed for is on the left side of the door, the upper left door, it's supposed to be less secure. And then if the user gets in and the sensors realize that this is somebody that's facetious in nature or doesn't know the lock or whatever, say the first authentication's I don't know, a keypad, we'll say. They get into that. They find out whatever the keypad is. They get into the second door. Maybe it's I don't know. We'll say it's a key or something. I don't know, just to be easy. And or maybe it's a thumbprint or something for biometrics. Anyway, the second door fails, whatever it might be. What happens to the first door is if the second door fails, the first door locks. Second door's locked, so they can't get out. And then they're caught into that area until authorities come. So a lot of businesses will have this. A lot of governmental offices have this, I know. And basically just a walkway that can be locked out and quarantined without anybody being in danger that works there. Securing devices, continuing on, access list just has a list of individuals who have permission to enter that secure area. And that access list, by the way, can be embedded in the door chips. You can embedded in proximity cards. Records time they entered and left. Man trap separates a secure from non-secure. Device monitors and controls 2 interlocking doors. Only one door may be open at a time. Video surveillance. We have video surveillance everywhere now. At your home, probably, some of you, and at work. Definitely at work, you probably have it. On campus, we have cameras everywhere now. All your hospitals have them, both external and internal. And so you can pretty much guess that anywhere you go, you're being filmed in some way, more than likely. Whether it be Walmart, whether it be the mall, driving down the road, at a stoplight, you're being filmed. So the video cameras transmit signal to receivers close by on closed circuit, or they can be fixed or able to move. And then fending is where barrier surrounds the secure area, like a secure fence, secure apparatus of some type, maybe a moat with water around it to where it's hard to get across or impossible to get across. Maybe a moat with water and alligators in the water. There you go. Maybe that. This is pretty cool stuff here they have for these surrounding technologies to stop people from getting in. The first here, I'll make it a little bit bigger here. It's anti-climb paint. You guys ever heard of that? Anti-climb paint is a non-toxic petroleum gel that's thickly applied, does not harden, and makes any coated surface very difficult to climb. Typically used on poles, downpipes, wall tops, and railings above head, like 8 feet or higher. Anti-climb collar, you've probably seen these. It's a spike collar that extends horizontally about 3 feet above the pole, preventing anyone from climbing. Serves as both a practical and visual deterrent. They have spikes that protect the equipment mounted on the poles, like a TV, or on 90, they have a number of these for clocking your speed, which I know people got tickets with that. Then the next last one, rollerblade or roller barrier, is independent rotating large cups on top of a fence to deter climbing over it. Around public grounds, schools, non-aggressive barriers, important. And then rotating spikes on top of gates, fences, and can be painted to blend into the fence. So securing hardware, physical security, we talked about a little bit. Portable devices can have steel brackets, security slots, like your laptops, your monitors, your computers can have steel cables, like the ceiling here has a steel cable for that projector. And most laptops, so there's a lot of laptops, they come with a little slot that you can use for steel cable or something to mount it. And then laptops can may be placed in a safe. Locking cabinets can be pre-wired for power, allowing them to be charged, like for tablets or laptops, either one. So here's an example of a cable lock. You've seen them before, maybe. It plugs in the side of the laptop, and then like IBM was the first laptops to do this with, as far as built into the laptop, because they were the first business grade laptop. and so then HP, and then just kept adding. And it has keys. Now, a lot of these keys are fairly easy to find, by the way. They're not real difficult to hack into those keys or to find a key. So a lot of these devices will have different types of locks, not just a key lock here like shown here. And then mobile device security, many security provisions can apply for mobile devices like remote wipe. You might have heard of that if you have iOS or Android, either one. There is a popular remote wipe. Somebody steals your phone, you lose it, whatever. You can log into it and remote wipe it, or find location. Or there has been instances where they've given it to police, and police have found phones and tablets and things like that from the location services being turned on the device. And it generally, I know for iOS, I believe it's the same way with Android. It doesn't cost any extra to do that. You just have to turn on location services and then go through a cloud to see where the device is at. GPS tracking can pinpoint within 100 meters location of that device if it's stolen. And then mobile devices do have a unique security feature like voice encryption to mask the voice of communication over a smartphone. And there's other types of encryption as well that's used, like thumbprint authentication. Voice is one, but I would say probably thumbprint's the most popular today on mobile devices. And then in a software application, any software, especially operating system software, 5 steps to protect the OS, develop some security policy, and some things better than nothing. It might just be starting out with password policy. Everybody has to have a password of 8 to 10 8 or more characters. Cannot be a word, cannot be a dictionary word. Has to have a number, a letter, a number of caps, and a special character or something in no specific order. And then performing host software baselining, where Microsoft has a product called Microsoft Baseline that you can run on all your computers to determine the health of those computers and any patches are missing and stuff, and how many computers have weak passwords built into them. And then configuring inside of that computer's operating system, maybe through like Active Directory, things like blocking out control panel from being used, blocking out ability to install apps, some type of settings and deploying the settings to all the other users would take that one computer you're using Active Directory on and getting it like you like it, and then deploying that to every computer on a network through Active Directory. So you could have different deployments for different departments. You have a department deployment for sales that gets to see all the database stuff. Bookmarks on the website on a browser already built in, regardless of what computer they go to maybe marketing. Doesn't see any sales stuff, but now they see all the folders and files on a network drive for everything for marketing, as well as maybe software like Adobe and some other applications that they might use. And then maybe IT, when they log in, gets more depending on the position of that person, might get full admin rights to everything they log into, and getting access to everything on a network globally. To maybe somebody in IT that just installs printers. That's all they do. So all they need is access to print driver folders, and that's it to do their work. So it depends upon the place, how hard they are with the security policies. And then finally, patch management, some type of patch management. Most IT departments block Microsoft website updates from being accessed within a building. That way they can manage their own patches for the company. Because a lot of these times these patches need to be tested on like a virtual environment before they're implemented. And there's tons of patch management tools out there that you can get that's totally open source, doesn't cost anything, to tens of thousands of dollars. And so here on campus, we do patch management once a month. Everybody keeps their computers on. They push the releases on that computer. It restarts it, and then when everybody comes in the next morning, everything's already updated for that computer or for that operating system. Policies also continuing on, document clarity defining organization's defense mechanisms. I'm a little leery on that one. I generally, for IT, that's fine, but for the general populace, generally don't allow some. You don't want all the defenses put out there as far as how you defend your network. Because if it's globally accessible, like say on a corporate site or intranet to everybody, kind of defeats the purpose sometimes on security. So there's some things like password policies, stuff like that, definitely that you can put on a document. And then host baselining on determining, okay, an example on this might be we want to be in 90 percentile or higher on antivirus updates on all of our systems. You say, well, why not 100%? Not going to happen, especially with a larger company where you have people, internal, external, on your host, on your environment. So 90 plus is good, a good percentage. And the ones that are not in that 90 percentile, you can then deal with individually to get them updated. But to have a baseline of 90% is pretty good. And then configuration settings that can be applied in Active Directory for what I already mentioned earlier for security aspects when you log into computers. To maybe, I don't know, putting ports on your Ethernet ports inside the building for people who can't access them. If you're on guest Wi-Fi, put it on maybe a DMZ port on your network. That way it doesn't access your real network. There's thousands of different settings inside of an operating system especially in Active Directory, tons of different ways to configure baseline. And I always tell students when we're playing with Active Directory, which you can buy like an Active Directory Bible, I was about that thing, just all Active Directory stuff. And we play with it one of these weeks where basically you can play with Active Directory settings, just don't close it out. Because if you close it out and you save stuff, you could lock yourself out of an operating system, which I've done before, playing with it. And so, like, block everything. I can't even get into the system. I'll block myself out. And so, now there is ways to recover that, by the way, but not real easy. And so, when we go over that week on Active Directory, really, if you play with it between now and then, just know if you ever play with it, just keep Active Directory open and don't close it. That way you can backtrack. And I always take pictures too of my operating system while I'm playing with it, before and after. I'll take a picture of what it looks like before I did anything on each screen. That way I can go back to that if I need to. So little tips like that. And that goes with anything you're working in technology. Before you start making changes, or whether it's building a PC to a network to configuring operating system security settings, use your phone camera, which is a good purpose to use it, is just take pictures of it, and that way you don't forget what it looked like. Easy. If you're like me, after about the fourth or fifth screen, you're going to forget. You're going to remember what it was like. On deploying settings, Active Directory has things like security templates, and this is generally done through Active Directory because you wouldn't want to do it per computer. It would just take too long. Active Directory would be a much easier way to do it because Active Directory would suck it down on people's login when they log in through group policy. And group policy is going to use Active Directory security template that you created to bring down that security policy to that computer wherever they're logged in. So you could be on the computer you're at and log in for sales or marketing, and then come over here and log onto this computer. You use the exact same settings. They bring it down from the network. So when a securing operating system, OSs have increased in size and complexity, as you can imagine, over time. from Windows 3.1 days. New attack tools have made secure functions vulnerable, like script kiddies and backdoors through vulnerability patches, security patches, general software update to cover just security vulnerabilities. Those generally need to be applied. So here's some code lines, examples of Linux, 5 million, FreeBSD, 9 million lines of code, Red Hat 30, Microsoft 750, I think 10's like around 60, 55, 60 million, something like that. Mac OS 10.4, 86 million, and Debian 324 million lines of code. That's a lot of code. But not really when you think about it, over the iteration of time, stuff gets added. And sometimes bugs never get fixed. Just, they get by. They're low-hanging fruit, so they sometimes never get fixed, possibly. I think one of the statements Bill Gates said a while back in an interview I was watching, he said that they wanted to get rid of Control-Delete like the second year in, because there was a lot of issues with it, with software and a whole bunch of stuff. But it was so embedded in documents and people were using it, they said, forget it. They just kept it. But security patches, one of the terms you've heard of before on your computers, you've seen it maybe, is hot fixes. Now, hot fixes are generally for, say we're IBM here, and we have a whole bunch of new hardware we've created in artificial intelligence, right? And we're a Microsoft shop, meaning we use all Microsoft OSs, and some of our hardware is not working so well with the operating system. That's a hotfix. Microsoft can actually create a hotfix just for IBM and their computers. But it's going to be globally accessible for everybody to get. But that doesn't mean you need it, okay? So hotfixes aren't so much for you and your customer needs as one customer somewhere. Service pack is accumulation of security updates. Usually at least once a year, security update, service pack comes up. Implement patch management, where you can basically do automatic updates from homegrown systems to expensive patch management. And patches can create problems sometimes, especially if you've not tested it before you deployed it. An example is a patch can cause people not to be able to log in the next morning. Everybody. Or can't access their email, or can't access a folder, something like that. So it's good to test it and have, what we generally do is just have a computer or two that have everything on it in a virtual environment and test those patches, and have people that use that software on that those computers in the business to test it, to see if it works okay. If there are any hiccups. Are you going to miss stuff still then? Definitely you can, but you're going to be less likely to the more testing you have. So here's an example of, and most of your home computers are set this way where they update so often, like maybe every night at 3 a.m. Or in businesses, a lot of times we'll turn that off because we want to control the patches ourselves. And we'll disallow people from even making a change on the screen. And you make those changes, by the way, of disallowing it through Active Directory. And you can just block them out. You might not even be able to access that screen and see it. So automatic patch update services through Microsoft, through whatever, Adobe, PDF, you name it, whatever software it is. Advantage of automatic patches: administrators can force updates to install by a specific date or every night. Computers not on the internet can receive updates. Users cannot disable or circumvent updates. And so here on campus, we do it once a month for updates. We just tell users to keep their computer on, and when they come in the next morning, everything's done. Here's an example of, say, RBC. We'll say RBC is the network here, and we'll say the vendor's online service, update service is, let's say, our antivirus software, and it pushes it to our automatic patch management, which in this case is going to push to all machines every hour, these updates. And for antivirus, it's generally every hour. not once a month. You don't want them once a month. You want every day. You want it all the time. And so it automatically patches them, updates them incrementally. That way it's not overbearing on the computers. If you do it once a day, it's going to take a few minutes maybe. Or if you do it incrementally throughout the day, every hour, it's not going to be many new DAT files that has to be updated. And what I mean by DAT files is all these, regardless what the antivirus system it is used, they all have what's called a .dat file, a DAT file that has all the files that are updated on the local computer that are to be blocked, basically, to put it easily, to understand it. And those DAT files are updated through the vendor, through people like you and I who submit issues with software or issues with something we found on the network, and we can submit that to, like, say, McAfee or whatever operating system, Norton maybe, that you use through antivirus, and they can update that patch file. So securing with anti-malware, antivirus basically software is needed now on every system, even phones, especially if you have Android. It's basically going to examine your computer for viruses, continually scan everything as documents are downloaded, as documents are uploaded, search for patterns, anomalies. Heuristics is a popular way to block antivirus software. We'll use heuristics, meaning this software is acting weird, but it's not on the list. We're going to block it anyway and quarantine it. Okay. Weakness of antivirus, vendor has continually searched for new viruses and update that file. And signatures. So that's why a lot of times they'll do things like code emulation or heuristics. You might have heard of that before. And heuristics is a pattern of a software doing malicious things or maybe malicious things and quarantining it just to make sure the user knows what's going on. Okay. Anti-spam, still around. Spammers distribute malware through email. The number one way malware is brought into systems today is still email. It can be used for social engineering, meaning, hey, click on this link and pay. It could be this. It could be somebody guising as a CEO of a company, of your company, saying, you know, we need to make a money order or do a withdrawal and give it to me by noon today. I have to have it for a client, whatever. Okay. Totally bogus. Social engineering to get people to do things they shouldn't. And then different types of filtering methods that are used on email filters, whitelisting, blacklisting, Bayesian filtering, blocking certain file attachments like executables being blocked. Definitely most email servers will block an executable that's attached. A BAT file will be blocked, a batch file, a .com file can be executed. A number of them. .jar file, a Java file can be blocked as well. And then you can also add different file attachments for your location into that blocking algorithm. Pop-up, not so much anymore today, but all of your browsers, by the way, if you download a new browser today, in the last year actually, all have pop-ups enabled, pop-up blocking's enabled on everything. And everybody knows what a pop-up blocker or pop-up is and pop-up blocker is. Firewalls. There's different types of firewalls. You have software-based firewalls and hardware-based firewalls. Firewall basically is going to block things coming into your network that doesn't need to go in to your network and things that go out that doesn't need to go out. It can be hardware, software-based. Windows 7 and even Windows 10 has 3 designations of the firewall. When you connect a new network, it can be public, it can be home, or it can be work. So when you connect a new Wi-Fi, you have those 3 criteria, and the user can configure separately. Public's going to be more locked down, not going to allow as much through. Home, more is going to be allowed through, and work even more, okay, to get your work done. And then monitoring in Windows and Linux and even in Macs. In the system settings of your computer is the ability to look at events, what's called events. Microsoft has events, Mac has events, Linux has events. And events would be like when people log in, when people log out, when a file operating system's updated. And or maybe say somebody fails a login attempt, that's logged as well. So logs are generally in IT audited every 6 months on a computer by computer basis. Some of them more than others, depending on where they're located and who's using that computer. So an audit log can go through and find things that people are doing they shouldn't be doing, or things that they aren't doing that they should be doing. And so you can also look at specific files or specific types of logging. You're limited in Microsoft, kind of what you can log. It's already default, going to log stuff already mentioned, like alerting you whenever, or alerting in the log when a log's failed or a log's been successful. A login's been successful or failed. So it also logs all activity from a network device, like every time something's connected to your computer, whether it be a network server, another computer, a phone, it's going to log that. Security setting alerts going to be logged. All these things are logged inside the events dialog within Microsoft. And the system event logs record client requests, server requests, user information, usage information, when you logged in, when you logged out, what your account's done, to antivirus security logs. Did patches fail? When did they fail? Did logins fail? When did they fail? Things like that. Now, these logs will not alert you of anything. You have to actually view the log yourself. And there's softwares like Microsoft Baseline that can scan your entire network, right? Hit each computer, find the logs, and then give you a report on what's what. You can say, I just want to find out how many computers have had failed login attempts in the last week. Well, over here, we've had one computer on the second floor. We could say it's every night at 9 o'clock has 5 login attempts that's failed. That's a red flag. So that's how you find stuff. It could be maintenance is trying to log in to check their email. I don't know, whatever, right? Could be the guy working in construction or whatever. I don't know. Or it could be the user themselves coming back and they have kids playing on it or something. I don't know. But in cases like that, a lot of times in the past, what we've done is put a camera up in that location, a pinhole camera or a portable camera, and you're like, whoa, that's invasion of privacy. Nope, it's not. They work there, everything's monitored. Most people, you yourself have done this, sign something from HR saying basically anything you do in that business can be monitored, right? So over the years, we have caught people in different businesses I've worked at, from stealing change out of drawers to people trying to log into computers to stealing keyboards and mouses and laptops at night, stuff like that, all through these little bitty cameras. Years ago, they were really expensive. Today, they're really cheap. Cameras are to find and to install or to move around, and you can do it fairly reasonable now. Sad you have to do that, but you have to. And security logs are one red flags that can help you to find out what's going on, or at least a red flag something's going on. Here's an example of a event viewer within Microsoft, within operating system Windows. You'll see on the left side, I'll blow it up a little bit here. On the left side, you got the event viewer, and then custom views, and then under here, Windows logs, application, security, setup, system, forward events. All the security ones will be things like logging in, logging out. There's a login attempt here, login attempt here, log on, so on and so forth. Okay, and if there was a failed one, it would also tell you that as well. And then the application Windows logs are going to tell you things like when applications have been updated, or if there's an update available. Setup will tell you how many applications have been installed on that computer, and what time, and who installed it. System will tell you what files have been updated recently, what files are missing. System files might be missing or corrupted. Forwarded emails or forwarded events. You can set up logs to forward automatically depending upon the log type. So I've set up in the past, if a log type is a failed login attempt, on that right column where it says task category, have it forwarded to my email or forwarded to a file, either one. And then underneath applications and services, a whole bunch of other different types of logs, hardware events, Internet Explorer events, key management services events, media center events, Microsoft Office diagnostic, sessions, PowerShell, and even subscriptions. So things you're subscribed to Microsoft can be modified or logged in here as well. And all that is on the right side. I'll show you that. We played with this one week when we're looking at Active Directory. But on the right side, you can see where you can filter the logs, and you can save them, attach them, and you can even have a help file that'll help you with whatever issues or questions you might have. This down here gives you the example here of a login was attempted using explicit credentials. Give the login name, security, that they logged in, and it was successful. So that's what the events page looks like in your computer. And you can access your computer management and your Windows operating system by right-clicking on computer and going to computer management to see this. Benefits of monitoring system logs, system policies, identifying security incidents like I've talked about, fraudulent activity, provide information shortly after events have occurred. And we use it all the time, like say somebody can't log in the next morning or everybody can't. Look at the events. It'll tell you what happened. If there's an update that caused it, it'll tell you that. Help identify operational trends, long-term problems, and compliance. And then here's an example of a Microsoft Security Essential baseline, blocking and detecting Trojans. 4 of them are keyloggers. And every one of them, it was said severe on the alert, and it removed them all, which it should. Application security, when you're securing applications of any type, you have to have development and the development of the application, hardening that application, and patch management for that application. Say it's Adobe PDF, which everybody uses. What's your patch management on that? Do you want Adobe driving it, or do you want the company to drive it? Most companies want to drive it themselves because Adobe has pushed out patches in the past that has crashed networks. And so they're a large company. Are they able to test every company in the world with that patch? No. So it's up to us to test it versus trusting Adobe to say, everything's great, you can push it out. Maybe not be the case. And I have known people, and you'll run into people that'll say, every patch that's in the patch store on Microsoft needs to be updated on a computer. Don't believe that. It's not true. I've seen it break a lot of stuff. I'd rather be out of date on patches than just be up to date to be up to date. Guarantee it every day of the week. Yep. When it comes to application development security, some phases, and this is part of my world through the day, is depending on the developing of the software, it'll be more secure, less secure, depending on the nature of the software, basically. Some software is based open for everybody to access, no security whatsoever. And some software I've built over the years is very granular in its security, meaning you can lock every single component of that application down if you want to. And only one person can access it, possibly. So when you're securing things for code, you have to do things like consistency, reliability, standards for reviews on code, errors, fixing errors, things like that. Error handling. What happens when they get an error handled? Does it just crash the system, or does a developer get a prompt of what happened so they can fix it and follow up on it? User response of an error, input validation of an error, making sure inputs are validated throughout the application, and output encoding, ensuring everything's treated properly, all the data is trapped, and then called fuzzing testing. This is a software technique that deliberately provides invalid, unexpected, and random data inputs and monitors to ensure all errors are trapped. It's called the break it mode, where you basically tell people a lot of times to break it on purpose to see if they can break it during the testing phase anyway, because you want them to find holes and stuff in it. So when it comes to application hardening, there's a couple ways attacks occur through the executable itself. Prevent this type of attack. You can prevent the application from creating or modifying executable files for its proper function. System tampering, another type of attack. The vulnerability here is modifying specific areas of, like, say, Windows registry or system startup files and taking advantage of those modifications. Defense do not allow modifications to modify applications to modify system areas in the operating system. Process spawning control, trick the vulnerable application into spawning executable files in the system. Defense for this, taking away the process spawning ability from the application. Patch management on regular applications, rare until recently. Last couple of years, been able to take over the patch management, custom patch management tools. And users are unaware of existence of patches and where to acquire them. Securing data, making sure that data is freely to flow within the network, and preventing loss of data is important. And one of the ways to prevent loss is making sure only those who need to see the data can see the data and have access to the data. So if they don't have access, they're not going to be able to hack into it or be attempted to hack into it. So don't allow them to even see the folder. Data loss prevention looks at things like data in use, like is things being printed that shouldn't be printed? Are things being transmitted that shouldn't be transmitted? Where's data being stored? Is it being stored in the cloud or on-site only? Maybe if it's in the cloud, if it's critical data, maybe we rethink that and take it out of the cloud. And then content inspection, looking at transactions, looking at for files that are modified. That way, files haven't been tampered with. Okay, so let's go and do a Kahoot real quick, and I'll get you out of here. So there's the pin for the Kahoot. And this is over what we just talked about. You gotta have the cheesy music with it. For those that are online, I did increase the time on the Kahoot to 30 seconds versus 20 seconds, so there's a lag online to the Kahoot. What's that? Just go to cont'd from your computer. Cont'd.it.com. And then you'll enter in that game pin. I got some good names here. Let's see. Air, like it. CDA, redacted. Good. Got a few more to add here. So remember, go to kahoot.it, enter in the game pin. About another 30 seconds when we get started. All right, here we go. Restricting access to equipment areas, physical security, software security, malware security, malware software. Physical security, software security, malware software. Physical security is the correct answer. Good job. Here's the leaderboard. Mantrap is not separated secure from a non-secure, separates the secure from a non-secure, or separates a secured area. And yes, that is a picture of Mantrap there. No, it's not. Maybe a bear trap. All right, so number or four, the four of you got right. Separates a secure from a non-secure is the correct answer. We have the two doors, secure, non-secure. Non-secure coming into the door, secure going into the second door. And it can only open one door at a time, remember, or one access at a time. When does OS 11 come out? iOS 11 come out? This is old. It's already came out. Yeah, I don't even know why I gave on the answer on this one. Just answer something. I'm guessing maybe today. I don't know. I'm probably wrong. Or next month, let me see. Today, okay. All right, disregard that one. What software had hidden malware placed in it recently? McAfee, CC Cleaner, or Norton? This one was not discussed. But it did happen a while back, about a year ago. And it's a popular one that's actually shown as the icon on the screen. Summer, yeah, around summer last year, like somewhere around there. You guys hear about that?
Yeah.
Okay, yeah. They updated and got rid of it. All right. Portable devices cannot be secured with a cable lock. True or false? False. Portable devices can be secured with a cable lock. Security policy must be created. True or false? True. Now, are they? No, probably not, but they should be. All right, so there is the leaderboard. Good job. All right, and Thursday when you guys come in, we're going to be doing the man in the middle attack. And so as soon as you come in on Thursday, you won't need to log in your computers. You'll just, I'll have more than likely have Facebook on your screens already, just as that will expedite the lab, and then show you how it works. The man in the middle will be active when you come in, and then we'll go over how that works, how that man in the middle attack works. And then when we shut the attack down, I'll have you come back to wherever computer I'm at in here to show you how the man in the middle attack collects data and how easy it is to set up, and some security ramifications that we can talk about to stop a man in the middle attack from occurring. So, all right, well, that's it for tonight. Be careful out on the roads. Supposed to blow and blow really hard and drifting and stuff. So be careful. And temps supposed to drop. So be careful. Thanks for coming tonight, and take your time on the way home. See you Thursday.
Have a good one.
Hey, we'll see you. Yeah, we'll see you.
Hey, guys, a question. Did we ever do last order last week?
We're doing it this Thursday.
We're doing this.
Yeah, we're doing the man in the
Okay.
middle. Yep.
All right, that's what I thought you said.
Yep. Yep. It was